Everyone, my name is Anvita Bansal and we are back with another lecture today. Before we move to the lecture, let me just check if you guys are able to see my screen. Just a second. Fine. So, let me show you the problem for today. So, I hope you all can see my screen now. This is the problem that we are going to discuss, which is kth smallest element. So, if you read the problem gives you an array, right? Which is obviously not sorted, and you need to find the kth smallest element in the array, right? And k will always be will be less than the size of your given array. How will you find this? Now, this problem has lots of approaches to solve. Now, if you check in the question, they expect you to solve within O(n) of time complexity, and this is the space complexity that you can use, right? So, how can we solve this problem? If this is the given array, right, you have to return 7. Why? I will tell you. Let's move to the whiteboard and understand this problem. Just a second. Okay. Let me just check if you guys are. Okay. So have a look here. If in this problem, let me move to the whiteboard. Okay. Just a second before I move ahead. I hope you all can see my screen. Right, you can. And before I move ahead, I just want to check. Okay, so I think it is visible now. So this is your test case here, which I have written right here. Okay, and just let's understand this problem in this way. You have to return, you are given k as 3. You want to return third smallest element. So what do you mean by third smallest element? Let's assume if this array was sorted, this sorted form of this array would have looked something like this: 7 and then 10, 15 and 20. If your k, I say k is 3, that is third smallest element, what would you return? This is your first smallest element, this is your second, this is your third smallest element. So you want to return 7. You get this thing, return 7. That's your third smallest element, right? Okay. Now, how can you solve this problem? Very simple thing that comes to almost everyone's mind who solves this problem, who wants to solve this problem. You sort the array and iterate over the array k times and then return the k 0, 1, 2, k minus 1th element from the array. But obviously, the intent of this problem is not for you to use this approach and solve the question, right? The intent is something else. Here, with this question, I'm going to introduce another. Actually, you already have learned quick sort, which I already have taken in my previous lecture. Here we are going to understand what is quick select algorithm, very similar to quick sort, and that's what we are going to use in this problem to solve it. So how does this algorithm work? You all know that always we start with taking some pivot element. So let's take the original array. Let me check if you. Okay, so let's take our original array. Just give me a second. Let me write it again. So your original array would look like this. Let's see how this quick sort algorithm is going to look like. So quick select, quite similar to what we studied in quick sort. So if you are not aware of quick sort algorithm, I would suggest you to go back to our quick sort problem, understand that, and then you come to this problem. It will be very easier. Let me write this test case now. 7, 10, 4, 3, 20 and 15. Okay, so let's start by taking a pivot. Again, I will take my pivot at the end. Okay, so I take, for this first iteration, let's take my pivot to be 15. In this case, I am taking 15 as my pivot. My pivot element is 15. Okay. Then what you do? Taking your pivot element, you iterate over your array and you do the partition. You do the partition in such a way that elements which are less than 15 are before 15 and all the elements greater than 15 are after 15. So the array's condition would now look like this after first partition. See, 7 is less than 15. This is how we do partition. I'm not going to go through every context of how we did partition, because I would recommend you to go and understand it in quick short lecture. So here 7, then 10 is also less than 15, 4 is also less than 15, 3 is also less than 15, 20 is greater than 15. That's where our iteration of j will stop and I will be present here by the end of all iterations, and we will be swapping 15 with 20. Right? Okay. Now tell me one thing. Our partition function is going to return us which index? 0, 1, 2, 3, 4 and 5. So partition function is always going to return you the index at where your pivot element is present. So you chose 15 as your pivot element. After just bringing it to its right position in your array, you will return 4, right? That is the index where your pivot element is present. Now your task in this quick actually select algorithm is, let's say you are finding kth smallest element. In that function, your task will be to compare where your pivot element is present now. So it is present at 4th index. Let's say idx is 4 right now, which you got from partition, and you will be given some k. Your task is to compare your k with idx or this partition element. When you see that your partition index is 4, right, which was returned by partition, and your k is 3. So ideally, in terms of index, your k should be 2, that is 3 minus 1. Why am I saying so? If you want third smallest element, so in terms of index, it will be 2th element in your array, right? If you index it, it will be 0, it will be 1, it will be 2. So you would want to return k minus 1th index, right? So you compare k minus 1 with your index idx which you have got from partition. Now what you check? You check that your index is 4 and k is 2, that is 3 minus 1. So 2 is less than this index. That means the element, that is second smallest element, you are going to get in this window of array. Why? Because pivot index tells you that this element is, if it is present at 4th index, all the elements before 4 are going to be smaller than 15, and you want to find second smallest element in terms of indexing, right? So you are going to get it before 4 only, right? So now you do one thing, apply this quick select algorithm or apply the same thing that you were doing for this window of array. So now you will pass again this kth function for same array, just that your range will get changed now. If you were passing low will be low, that is the lowest index. Your high index earlier was this index, now it will become your partition minus 1 index, right? So you can make it as idx minus 1 because you have stored it in idx. Just for your understanding right now, when we will code, you will understand it obviously. This will become your high index, right? That's what you're passing. Okay, if now now in this function again we are going to do the same thing. Check out the last, what will be the pivot element. Let's take the last element as a pivot element. When you chose 3 as your pivot element, you do the comparisons. 7 is greater than 3, so obviously 3 will be swapped, 7 will come here, right? Okay, and then you come at 10, 4, 3, all are greater than that, so it will become something like this. You getting this? Actually don't even need it to swap it. It should be something, by the end of the iteration, when you chose 3 as your pivot, what will partition do? Initially both your low and high index will be at this position, basically I and j will be at this index. It will check if the element is greater, j plus plus, I will still stay here. j plus plus. Now end of iteration, you will swap I with pivot index element, so it will become 3, the one we wrote, 10, 4, 7, and rest will be 15, 20 as they were. Now your window size was what? Your window size was this, and from here you got your pivot element at which position? You got it at 0th index, right? You got it at 0th index. So 1, 2, 3, right? Now you got your idx as 0. Compare it with your k minus 1. K minus 1 is 2. Now, sorry, idx is 0. idx is 0. Why? This is the position where your pivot element is now present. So partition will return you this index. So since your idx is 0, 0 will be compared with 2. 2 is greater than 0. So one thing is for sure, that you are going to get your third largest element within this range. If you are going to get within this range, now you will apply recursion or the same function call of quick select or kth smallest element. Smallest, that is the function we are using in your problem again. And now in this case, your low index will be idx, same arr will be passed, right? Your low this time will be idx plus 1, right? So it will become idx plus 1. Idx was the position where your pivot element is present after the partitioning thing. So idx plus 1, and high will be what? So earlier also the high was this, so now also high will be same. So this is how your next time, for next iteration, it will look, your function will look like this. So now you are iterating, you're going to process over this range of elements. So you are seeing how we are making the range of the elements we are processing at every step. They are getting smaller, and the window size is shrinking at every step. Okay. Now for this array, let's make this as the partition array, right? Now if you make this as partition element, then you do the partition and you compare. 10 is greater than 7. Basically ij starts with here, as and when we get greater, you do j plus plus. Now this is smaller, you will swap 7. You will, now when your I was here, see, now the situation is like this. It should look 4, 7, 10. After your partition function has taken place, you have called your partition function. This is how your array is going to look like. This is your pivot that you chose. Okay, initially again, okay, I am iterating over this. I starts from here. This time your low is idx plus 1, and which will be this element. High is still this. Okay, you are here, you compare. If you get an element which is greater than your own value, then you do nothing, just come ahead, and I will be there, j will be here. As and when you get a smaller element, you swap it. 7 will come here, and I don't know what is happening. I think this should be swapped. Okay, just a second. Why is it getting? Let me check the iterations. 10, 4, 7. Greater, we don't do anything. For smaller, we swap it, and then that's how it looks like. And fine, it's right. Yeah, so 4 gets swapped with 7, right? 7 comes here, 4 comes here. After the iteration, after the entire iteration, you remember that we swap arr of I with partition element, right? I is still at this index and your partition element is at this index. So when both are swapped, it will become 7. Sorry, this is the partition index. It will be 4, this will be 10, and here will be 7. So that's how we will get. So partition will do its own work. Okay, now you are at this index. Where did your pivot element go? Your pivot element is at this position. What is this position? This position is 0, 1, 2. Ideally this is for our understanding, but according to array, what is this position? So this position is 1, this is 2, this is 3. Now your pivot, that is 7, is at position 2, and your k minus 1 is also 2. When you get k equal to pivot, that means that is exactly the element that you should return. So you will return arr of pivot. You understood how we are iterating over this array? So I hope this is clear to you. Let me just check if you have any doubts. Okay, So any doubt so far, you can tell me. Coming back to the whiteboard, what did we do? See, we are using a partition index. Partition is taking a pivot element. It brings the pivot element to its correct position. That is the function of partition function, its correct position in your array. And then that position is passed to your kth smallest element function, which you are processing, in which you are doing all the other operations. And then whatever k you have, you compare your k minus low. Basically, k minus 1 is compared with whatever index your partition has returned, compared with partition's return value. Okay, you compare it. If you get k minus 1 equal to your index, let's say this is idx, what it is returning, we are storing it in idx. If that is equal to idx, you simply return arr of idx or k minus 1, anything would work. Otherwise, there are two cases. Either your k minus 1 is greater than what? It is greater than your low. Basically, now you are calculating the range. If it is greater than your index value, that means it is lying somewhere between idx plus 1 to high, right? So you will call the function, you will call a recursive call, you will make a recursive call for the same function for low's range to be this and high's range to be for your window from idx plus 1 to high. In other case, in this case you are returning this. In other case, you can make it if. Otherwise, else, what do? You return the same function with the range will be from your low to idx. That's what you are doing. I hope this is clear. Also, apparently, one thing that I wanted to tell you is, when you are processing over this part of your array, that means when your low is 0 and there is some idx till that is the window size, some in idx, that is the window size of your array which you are processing. So let's say if k is within, obviously k is within this window only, that is why we are processing. So whenever the k range lies from, that is your k is less than equal to idx and greater than or equal to 0, in that case you can simply do k minus low, right? If let's say this is your low and this is your high index, right? In that case you can simply say k minus low minus 1, depending upon how we will do. So k will lie between this range. But if your low is idx plus 1, right, and high is high only, in that case you need to manipulate your k, because see, now you are within this window where let's say your low is 5, your high is let's say 8, and your k is 6. So ideally, or let's say your k is 7, so ideally you need to find 6th smallest index in an array whose size is 9, that is high plus 1. High is the last position of your array, right? And low is some intermediate idx plus 1 that over which you are iterating. So I just want to explain you, according to your window, your k will also change if the window is somewhere from idx plus 1 to high, where, right, not from low to idx. That's what I'm trying to explain to you. So in this case, if you check your 7, so you can manipulate it something like this, that it becomes k is 7, right? And you want to ensure that it lies within this window. So for that we will do some manipulations, which I will, when code, I will explain you what we are doing. Okay, so is the question clear till here? Okay, so if you have trouble using recursion, I told you there are other approaches as well. You can use, the best method to solve this problem is using min heap or max heap, whatever you want depending upon the problem. Since here you want kth smallest element, you can use min heap. In min heap, the top of the heap gives you the smallest element, and as in when you keep removing, you keep getting kth smallest element from min heap. So this is one approach that you can use. But since in SDE sheet we are over this searching and sorting topic, so I am explaining this method using quick select, which is actually a variation of quick sort. Quick sort is a sorting technique which happens to take place, right? And this is just a variation of quick select, is just a variation of quick sort. And this problem that we have discussed, at max it takes, in worst case I will tell you, in average case this question passes in on of time complexity. Because see, even though we are making recursive calls, but at max it iterates, it goes over all the elements only once at max. In the worst case time complexity will be when we choose a pivot element such that, which is the extreme, either it is the smallest, the element that we are trying to find, it is the smallest element such that we find it in by the end of all iterations. So in that case the worst case time complexity is O(n) square. And since we are making recursive calls, so the space complexity, if recursive calls where they are being made, if that stack space we consider, then in that case it will take some O(n) log n of time of space complexity. So that is about this problem. And now let's move to the code and understand it. So those who want to do it using some other approach like max heap, min heap approach, or any other approach, either you will have to wait till we reach to the heaps topic, or I'd suggest try to understand this problem and wait until we go to recursion. There I will be explaining recursion, because recursion forms the basis of lots of questions. Without recursion you can't do DP, and DP is that topic which is extremely asked in interviews and many companies interviews. So you'll have to get a good grip over recursion. Okay, so let's move to the code now. So just give me a second. Fine, let's move to the problem. Just a second. Should stop. Okay, so let's start with our solution. First thing, I am going to write a partition function. Partition is going to take my array, a low index and a high index. Okay, and let's say int pivot also, which I will be passing through this function. Now what? Now you are taking some I at low int, and let's start our iteration. For int, your j is also starting at low. J is less than or equal to high minus 1, because your pivot is already at high, right? So we are going to run iteration till high minus 1 and j plus plus. If ARR of j is less than or equal to your pivot element, then you swap int temp ARR of j. Now what you will swap? You will swap your j with what? I'll tell you. Temp. Okay, so if ARR of j comes out to be smaller than your pivot element, you swap ARR of I with j, right? So let it be ARR of I, and ARR of I, store it with j, and ARR of j is temp. That's what you do. Okay, now you simultaneously increment the count of I. In other case, if your ARR of j is greater than pivot, you simply increment the count of j. Once you are out of the loop, as I explained you in one of our test cases, then you have to also do what? You have to swap ARR of I with pivot element. So in temp is ARR of I. ARR of I will be your pivot, and your pivot is temp. That's how you are partitioning. And finally you return I, the index where your I index is present. That is what you want to return. That will tell you the right position of where your pivot element will be present. Okay, now in this problem you will check, first of all you will take a partition pivot element. Your pivot will be your ARR of right. This here they have taken R as high, we have taken high, they have taken right R. So I hope you can understand this thing. Now one important thing, if now we are going to call recursion, but recursion is within certain ranges, and we have to ensure that k is greater than or equal to 0 whatever ranges we are in, and k is less than, what should be the maximum range of k? In that case it should be something like R minus L plus 1. That is, I will explain you why it is so, right? This will give you the maximum range of k. Okay, now what you are checking? You are checking that if, just a second, let me check if you guys are able to see my screen. Just okay, fine, I think you are cool. So what I have to do now is I will check that index that my partition will be returning. So let me take it as pop, and I will call my partition function, right? Partition function will be called with these arguments, where your low is L, high is R, and you are passing pivot. That will be your pivot, right? Fine. Now you will check if your position is exactly equal to k minus 1, then what? If position is equal to k minus 1, you simply return ARR of pose or k minus 1, right? That means you have gotten your answer. Otherwise, what can be the condition? I told you, if either your k lies somewhere between low to that position or somewhere between position to high. So you check that if k minus 1 is greater than your pose index, that means you have to check for the next half of your, right, next half of your array. So also, since we are iterating over this k in the terms of range, the window that we have taken, so we are going to compare k minus 1 with position minus that smallest low index, right? So if your k minus 1, if it comes out to be less than, let's take it less than position minus L, here also, because we want to confine within the range, then what do you do? It means if it is less than your position minus L, it means you have to iterate over, just make a recursive call to this function kth smallest with parameters as L will be your L, your R will be IDX, okay, and this will become, see, IDX minus 1 ideally, because we are including the rightmost index as well. So in this case your window size will become L to that IDX position minus 1, and k will be passed as it is. Fine. Okay, in the other case, if k is in the other half of your array, you would want to return the similar function but with these arguments. Otherwise you return ARR L will this time be idx plus 1. It will be idx minus 1. Now it will be idx plus 1. High will be what? High will be r, and k will be k minus your low, right? K minus low, k minus position. It should be k minus position plus low and minus 1. Okay, that's what you want to return. And once you are out of this loop, you will return, that means you haven't found any such value, you can return integer dot anything, like you can return integer dot max value. Okay, so this is how we are calling partition function, which is returning us the index. We are comparing position minus L. If that comes out to be the given k minus 1, we are returning. Otherwise there are two cases, either your k minus 1 is less than that value, otherwise it is greater, it is in the other half, right? And for the other half you do this thing. So let's check, and since I have written pose, it will be pose k minus position plus L minus 1, and let's check now. Please check the screen, code is not visible. Oh sorry, you guys are not able to see the code. Give me a second. I will explain you what we have done here. So there is some mistake here, let me check. Your code's output is 3. What is the issue? Are you guys able to see the screen now? Okay. Fine. You can see it. Okay. So let me check it. Just a second. I hope you are seeing my screen. Let me check. Yes, you are. Okay, so I wanted to tell, first of all, let's check where it is not working, what went wrong here, and let me just check that thing. I think we don't need to, I think I can give the pivot. Am I passing some pivot here? Okay. Just a second. Let me do one thing. Just hanging. Yeah. First of all, the range should be like this. Okay, should be less than. And let's do one thing. Instead of passing pivot here, let me just define a pivot here only. So we'll do ARR of high. Fine. And what else? Partition was called. No need of this. Fine. Let's check. Yeah, this thing should be removed. Still it is not working. Let's check, guys, what is the error. So even if I see that you have written a partition, right, array low, and there is this high. Fine. You fine guys are able to see it, right? Fine. Okay, let me check what is the error here. Then you have your pivot, which is your ARR of high. I think this is what is it saying. It is failing. What am I returning? Return ARR of pose. That is fine. K minus 1 is less than your position minus L. That is also fine. And then you are returning position plus 1. Right will remain that the range will be this. K minus position plus low minus 1. Otherwise you are returning max value. This is fine. What is the error then? Oh, sorry. This is the highest index that you are passing. Error of high index, right? Error of high is temp. Let's check. So guys, I'll tell you again what we did. So the issue was in the partition function. First thing, the partition is the conventional way that we used in the quick sort. So I am assuming you should know this beforehand. Now the entire thing was, let me just bring my whiteboard. See, so if I see here, 1 second, let me get my, okay, what are we doing in this question is that when you check, 1 second, both the screens are visible or not? Okay, so in this problem the explanation part comes here when we are doing the quick select. Let me get back to that. Navigating pages is becoming a little hectic for me in this OBS. Okay, so what have we done here? You are using your kth smallest, right? In this, whenever you check that your position that is being returned by partition, and what is that position? That is the index at which your pivot element should be present if it is at its right position, and you compare with k minus 1, right? If it is same, you return. Otherwise, either it is in the left half of your position index or it is in the right half of your position index. Accordingly, you do the recursive calls as per the right ranges, and that's how you return. So just, even if you haven't understood it, go through the problem that we discussed on the whiteboard, on the blackboard. Just go through the iterations and you will understand this problem. So this is all about it. If you have any doubts, you can ask me. Fine, everyone, let's end it. That's all for today. Thank you.